What about others? All of you have taken this problem at least? Students? All of you have taken? Am I audible?
Yes, sir. Yes.
Yes, sir.
Yes,
All
sir.
of you have taken, all of you have solved. So it is a cubical furnace of 50 by 50 by 50 centimeter on the side. And see, in the last class, we solved two problems, right? With conduction shape factor, problem number 1 and 3. Am I correct?
Yes, sir.
Am I correct, students? Problem number 2, have you solved? What here? No response is there. Whether you people are there or not.
There, sir. There.
Yeah. What about the previous problem? Problem number 2, I asked you to solve, right? Okay, I didn't upload. I'm sorry. Okay, I will upload it today. But this problem, have you taken the question and have you solved it?
Yes, sir.
Have you solved it or you want me to solve? Students, please say anything here. How many students were there?
Yes, sir.
54 students were there out of 54. See, I think, I hope all of you have seen your marks, right? The class average is 17, 17.01, just 17. So it shows that where you stand. Please understand that the whole overall class average is very less, only 17. So around 17 or 18 students, 16 or 17 students, I think they have failed in the subject. So it's a very hard or it's very difficult for them to improve unless otherwise they follow. I don't want to spell out the names here. And if you don't follow the classes, it's you are going to fail miserably. Please understand that. Yeah, we know that when we solve problems with conduction shape factor, what is the formula? K into S into del T, right? Am I correct or not?
Yes, sir.
Yes,
Yes,
sir.
sir.
K is nothing but the thermal conductivity. S is nothing but the conduction shape factor, and T1 minus T2 is del T. Okay. Now in this problem, a cubicle is given, right? In this problem, a cubicle is given. Let me copy it. And the conduction shape factor for wall is S equal to A by L, area divided by L. L is nothing but the thickness. Okay, in the diagram it is shown here. And edge is 0.54 D. Okay, and D is nothing but the height. And corners for corners 0.15 into L. L is nothing but the thickness. Okay, so the conduction shape factor for walls, edges, and corners were given. Okay, you may ask a question, sir. In data book, how can I find it? HMT data book. Okay, in HMT data book also it's there. Students, all of you are able to take the data book at what page it is. So when you come for the offline classes, you are expected, even for the laboratory classes, you are expected to bring the HMT data book. Please understand that. Is it okay?
Okay, sir.
Yes, sir. Okay, sir. Yes, sir.
And especially for the pin apparatus experiment without HMT data book, it is very difficult to write the formula. Not only for the class, even for the FAT exam. You can refer the HMT data book, especially for formulas, and you can write. Conduction shape factor. What is the page number here? This is. All of you are able to see this?
Yes, sir.
So here L is nothing but the thickness, D is nothing but the height. Okay, D is nothing but the height, and for edge D is nothing but the width. How wide it is, how wide the edge is, and for similarly the height. Okay, so L is nothing but the thickness. Okay, so walls is A by L, conduction shape factor is A by L, and for edges 0.54 D, and for corners 0.15 L. Okay, so it's there just below the conduction shape factor in page number 52. For new data book, it will be different. Formula is Q equal to S, K into S into del T, where S is nothing but the conduction shape factor. Is it fine, students? Everyone?
Yes, sir.
Okay, now a small cubicle. Okay, now a small cubicle is given. So, uh, I will solve this problem. You are supposed to solve the next one. Okay. So now you have a small cubicle, 50 by 50 by 50 centimeter, and thickness is 10 centimeter, and thermal conductivity is 1.04. The inside surface is maintained at 500 degrees C, and the outside surface is maintained at 50 degrees C. Calculate the heat transfer through the walls. So now a small cubicle it was mentioned. Okay, so if it is a cubicle, kindly bear with me because I am writing with on a very smooth surface. Okay, the cubicle will be like this. Is it fine, students? Is it fine?
Yes, sir.
Yes, sir.
And the thickness. Okay, let me draw the thickness on one side. Okay, it will be more or less like this. Okay. So you will be having it in all the four sides. Is it fine? Is it fine?
Fine, sir.
Yes,
Okay,
sir.
ma. Now it was mentioned here in the data book for walls it is A by L. So how many walls were there?
6.
6. Okay. So for walls it is, what is the conduction shape factor? It is
0.54.
walls it is
A
A
by
by
L.
L. Okay. A by L, where A is nothing but the area, L is nothing but the thickness. Area by thickness. Since it is a cubicle, okay, you can assume side 1, side 2, side 3, side 4, and top surface and bottom surface. Is it fine, students?
Yes, sir.
Is it fine?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Now, shape factor is area 0.5 50 centimeter. Okay. So 50 centimeter, which is equal to 0.5 meters. Okay. So 0.5 into 0.5 divided by the thickness. Thickness is 10 centimeter. Okay. 0.1. How much it is?
Sir, one doubt, sir.
Yeah.
Sir, if the furnace height and breadth is 50 centimeters, sir, and thickness is 10 centimeters, shouldn't it be 70 centimeters? So, like the length and breadth of the wall.
See, listen,
Of
it
one
is
side.
50 by 50 by 50. 50, 50, 50. Okay. This is 50.
But on all sides, the walls is there. So, like thickness of 10 centimeters.
Yeah. 50, 50, 50. We are considering only this surface. The area will be 0.5 into 0.5. So if you consider that 0.1 also, then it becomes the volume, not the area.
No, sir, not like that, sir. Like if we consider that the wall is there in all the 6 sides,
Yeah.
then the length and breadth of one side of the wall will be greater than the furnace alone. No, sir.
No, see, the assumption is from the inner side to the outer side, the heat is transferred. From the inner side to the outer side is heat is transferred. So the inner side you will be having 0.5 by 0.5 only. That will be the area. We are talking for only this surface.
Okay, sir. Okay.
Okay, we are talking only for this surface, this surface, this surface. So we are considering the area, and conduction shape factor, it was found as area divided by its thickness, because the heat is transferred in this direction. Okay, in this direction. Okay, it's a multi-dimensional heat transfer, right?
Yes, sir.
So we will be having this 0.25 divided by 0.1. How much it is? Sorry,
2.5.
not 25.
2.5.
2.5. Is it
Yes,
correct?
sir.
Sir, 2.5, sir.
Okay. Now this is for walls. Now the second one is for edges. Now how many edges will be there in a cubicle? How many edges will be there? 1, 2, 3, 4. Yeah, how many edges and how many corners? See, imagine your room. Imagine your room as a cubicle. So how many edges will be there? Top 4, bottom 4,
8.
and then
8,
vertical
sir.
edges 4.
12.
So totally
12, sir.
12. So totally it is 12.
12.
Okay. Totally it is 12. Okay. So edges. So yes, for edges, conduction shape factor for edges is 0.54 times of D. So 0.54 times of D. So 0.54 into the width, which is again 0.5 meters. How much it is? Please
Zero
tell.
point 0.27.
0.27 or 0.27?
0.2.
0.27.
Okay, okay, 0.27. Now, similarly for corners. Now, how many corners will be there? How many corners will be there?
8.
Please take your room, yeah.
8.
Edges, corners. Engineering graphics, I don't know what you studied in first year. 0.154 into L. 0.15, sorry, 0.15 into L. Am I correct? Yeah. 0.15 into L. How much it is? 0.15. L is nothing but it stands, that is, they say L as the thickness. The thickness is 0.1. L is equal to 0.1. D equal to 0.5 meters and L equal to 0.1 meters. Okay. So 0.1. How much it is? 0.15
0.015.
as it is. Okay. Not 1.5 or 1.5?
0.15.
0.15. Yeah, that's correct.
Excuse me, sir.
Yeah.
Sir, if the given question is a cuboid, then what will be the area, sir? Area by length.
Again, if it is a cuboid, you have to take the see, for different surfaces only it is given. That distance, you don't take it as D. D is mentioned as the particular distance from one side to another side or one corner to another side, corner. Okay. And similarly here also D is mentioned like that. Okay. So for walls, area divided by length. So wall, it is fine. For edges, it is 0.54 into D. So from one edge to another edge, you have to calculate. Okay. So now here in this case, we have how many edges? 12 edges. Okay. So there, if it is a cuboid, the conduction shape factor for different edges will be different. We have to find it out individually.
Sir, the area will differ, no, sir?
Area, we don't bother about the area for conduction shape factor for edges, right?
No, sir. For walls, I'm asking.
For walls, the area will be different. You have to find wall 1, wall 2, wall 3, wall 4, wall 5, wall 6.
Okay, sir. Okay.
Okay.
Yes, sir.
What your question is right, because in our house we don't have in the form of cubicle. Actually, the rooms will be of rectangular shape or sometimes square shape, etc. I understand that. Okay, so then you have to find it individually. See, that's why I have found out the conduction shape factor first, and then after finding out this shape factor, and finally we have to find out how many edges, how many corners were there. So we have how many corners in our house? In the cubicle, I'm sorry. In the cubicle, how many corners?
8, sir.
8 corners. Top A, B, C, D, bottom E, D, F. See, all these things you might have studied in engineering drawing. Top A, B, C, D, bottom E, F, G, H. I think the engineering graphics is very, very important. That's why engineering graphics and machine drawing is engineering drawing and machine drawing is very, very important subject for mechanical engineers. But you people, you never study that. That's a problem. Okay. And for when we talk about edges, okay. So when we name it as A, B, C, D at the top and E, F, G, H at the bottom, A to E, A to B, like that. Okay, so what we have is 1, 2, 3, 4 at the top, 1, 2, 3, 4 at the bottom, and vertical edges 4 edges. So totally 12 edges. Okay, and corners, when we talk about corners, top 4 A, B, C, D, bottom E, F, G, H. Okay, so 8 corners, 12 edges, 8 corners, and 6 walls. Okay, some of them they say 4 walls, sir. Actually, 4 wall is not correct. Actually, the top surface and bottom surface has to be included. And we have taken this 2.5, 0.27, and 0.05. Now, what we have to do is we have to, now you can find the solution here. 2.5, 0.27, 0.015 meters. Okay, and you can see here it is calculated 6 into 2.5 because 6 walls, 12 edges, 8 corners. So 18.36, and the final solution is 8.592. All of you are able to see this?
Yes, sir.
Yes,
Am I
sir.
correct?
Yes,
sir.
sir.
So the total conduction shape factor, which includes 6 wall, 12 edges, and 8 corners. Is it visible to you?
Yes, sir.
Please take it down faster. Our answers are right? 2.5 meters, 0.27 meters, and
Yes, sir.
0.1, not 1.5. Yeah. Yeah, I missed the meters, ma. I'm sorry. Meters, meters, and meters. All of you have taken down this? Shall I move on?
Yes, sir.
All of you? Students, all of you have taken?
Yes, sir.
Yes, sir.
Okay. The same type you have a furnace of 3 meter, 2.5 meter, 2 meter having thickness 200 mm with thermal conductivity 1.3, and the temperatures were 250 degrees and 50 degrees. So the same type of problem you try to solve this. Okay, because solving the same type that is again it will take so much problem, sorry, so much time. So let me put it this in the I think in the message box it's there, right? Sorry, chat box.
Yes, sir.
Students, you try to solve this, okay? And when you come for Thursday's class, I will be asking you the answer. Is it fine?
Fine,
Is
sir.
it fine, students? The same thing, only the change in values, nothing else. Am I correct?
Sir. Yes, sir.
Only the change in values. There it is 550, here 250 and 250, and the change in values 3 meters, 2.5 meters, 2 meters. That is the only thing. Is it fine, ma?
Yes, sir. Yes, sir.
But here the area will be varying. Whether you will be able to understand this, the area won't be constant, and you will not consider 12. Sorry, 6. Two sides you will be having different shape factor. Two sides you will be having different shape factor, and two sides you will be having different shape factor. Do you want me to solve or you can solve?
We can solve, sir.
We can solve, sir.
Yes? All of you are confident?
Yes, sir.
Yes, sir.
See here, the same thing is there, 50 by 50 by 50. Okay, let me give the idea and then. But here the area is different. 3 meter, 2.5 meter, 2 meter. Okay, so 3, 2.5 and 2. 3, 2.5. I'm sorry. It will be like this. Okay, students?
Yes, sir. Okay, sir.
One is 3, one is 2.5, the other one is 2. Okay, students. Okay, so the conduction shape factor for this side and which is opposite to this will be same. Am I correct, students? The conduction shape factor for this side and this side will be same, and top surface and bottom surface will be same. And for this side and the front side and back side will be same. All of you are able to understand this, or you want me to
Yes, sir.
solve?
No,
See,
sir.
S will be
We can.
two sides will be same, and for top and bottom will be same. S for top and bottom, for front and back, and S for two sides, left side, LHS and RHS. Okay, students. So the front and back will be same, top and bottom will be same, and left hand side and right hand side will be same. Okay, students. All of you are able to understand this?
Yes, sir. Yes, sir.
Okay, in the previous problem, what we done is we have divided, that is, we have multiplied it by 6. Okay, so the conduction shape factor for walls is same. Here, the conduction shape factor for walls, especially top and bottom, will be different. Two sides will be different, and front side and back side will be different. That's what I am trying to say. All of you are able to understand this?
Yes, sir. Yes, sir.
All of you are able to understand this? 3, 2.5, 2. So this area is 2.5 into 2. So this area is, the bottom surface area is 3 into 2.5. And the top surface area is again 3 into 2.5. And the two sides were 2.5 into 2. And front face and back face is 3 into 2.5. Sorry, 3 into 2. Is it okay?
Yes, sir. Okay, sir.
Front side area is 3 into 2. Side area is 2.5 into 2. Okay, and top and bottom is 3 into 2.5. Okay, like that you have to solve the area, and you have to find out. Is it fine? Is it fine, students? You will
Yes,
be
sir.
able to solve it, right?
Yes,
Shall I move
sir.
on to the
Yes.
next?
Yes, sir. Sir, one more thing, sir. In the previous question, the first one that we solved, sir.
Yeah,
In the last sentence, they've asked like calculate the heat loss through walls only, no, sir. But why
Yeah.
are we finding the other edge and corner?
no, calculate the heat transfer through the walls. See, agents corners, we are supposed to find out, right?
So if they mention heat transfer
No,
through
no,
wall,
no.
they
Calculate the
include
heat loss through the walls. See, the through actually what you're saying is the walls mean 1, 2, 3, 4. The four sides. Am I correct? You are
Okay,
talking
sir.
about that.
I got it, sir. Got it, sir.
Yeah, you are talking about that. But what happens is in a two-dimensional heat transfer or in a three-dimensional heat transfer, the heat transfer will be there in all the surfaces. Whether it is wall, whether it is a corner, whether it is an edge, the heat is transferred. Even when we take our house, right? When we take our house, the heat, the sun's radiation, we are getting it from all the directions. And even when switch on AC, the heat transfer from outside to inside, it will be occurring in all the directions. It will be occurring through the edges. It will be occurring to the bottom surface. It will be occurring to the top surface also. Of course, if it is bottom surfaces, concrete, or it is a soil, right? From the soil to the concrete, there will be some heat transfer. right? And in case of multi-story buildings, you especially the persons who live in apartments, right? You may feel it, because in the ground floor, if they switch on the AC, even we will feel the chillness in the first floor. I don't know how many of you have experienced it. I have experienced it, right? I have experienced it. If in the ground floor, if they have one AC in their room, okay, I will be experiencing the chillness at the top. Am I correct?
Yes, sir.
Yes, sir.
I don't know, especially those people who are in apartments, they experience it. Is it fine? So
Yes, sir.
you have to consider all edges, corners, everything. Okay, students?
I got it.
Yeah.
Like the wall is split into three parts. Sir, like
Yeah,
corners, edges, and-
yes.
Okay.
Okay, ma. This is yeah, so you will be solving this, right? No need for me. See, I have given the thing. Only thing is, instead of 6, you will be having 2 into conduction shape factor for bottom surface and top surface, 2 into conduction shape factor for left hand side and right hand side, and 2 into conduction shape factor for front and back side. Is it fine?
Yes, sir.
Yes, sir.
So the front side area and back side area is 3 into 2, and the left hand side and right hand side area is 2.5 into 2, and the top surface and bottom surface area is 3 into 2.5, 3 into 2.5. Is it correct?
Yes, sir.
Yes, sir.
Okay, ma. Okay, fine. Okay, ma. So we will move on to the next one. We will move on to the next one. The next one is finite difference method, ma. So now what happens is, so far we have discussed about graphical method and partial derivative method. By means of partial derivatives, we can find out. Okay. So, but usually, generally in engineering mathematics, you will be studying this nodal network or finite difference method. Okay. So this is very, very important method, and we can solve. We can find out. We can find out the temperature at each and every node. Okay, for example, if you have a plate, for example, if you have a plate like this, assume that a rectangular plate like this. Okay, assume a rectangular plate like this, and what happens is, this surface, it is exposed to, say, for example, 25 degrees C, and this surface also 25 degrees C, and this surface 25 degrees C. And if you have the heating element here, and if the heating element is there, and this surface may be exposed to around 60 degrees or 100 degrees C. This is what happens in case of iron boxes, right? So in case of iron boxes, you will be having the heating element, and the heating element will be transferring the heat to the that is the bottom of the iron box. Okay, so that the surface gets heated, and then what happens is, you will be ironing the cloths, so that what happens is, the heat is transferred from the iron box to the cloth which we iron. Okay, now what happens is, usually this surface will be divided into equally like this, okay, and you will be having so many interior points. Okay, so many interior points. For example, 1, 2, 3, 4, 5, etc. Okay, and similarly 6, 7, 8, 9, 10, etc. Okay, and similarly 11, 12 to 15, up to 15. Am I correct, students? 11, 12, 13, 14, 15. Am I correct?
Yes, sir.
Students? Now the rule is, this is if this is x-axis and this is y-axis, this is del y, and this is del x. Okay, along the x-axis you will be having del, and along y-axis or z-axis, okay, you will be having del z. Okay, del y or del z. Is it fine?
Yes, sir.
Yes, sir.
Okay, now we will be getting equation for these 15 points. Okay, and After getting that equations, we can fed it to computer and we can find out what is the temperature at each and every nodes. Okay, so that when this side is at 25, this side is at 25, and one side is at 60, then naturally heat transfer takes place from the 60 sides to the other one. So T1 and T2, T1, T2, T3, T4, T5 will be at a higher temperatures when compared to T6 to T10, and T11 to T15 will be much more lower when compared to T1 to T5. Okay, so now how to solve this? To solve this, we have this finite difference method technique. Okay, and again the assumptions were it is two-dimensional. Okay, and there is no interheat generation, and the thermal and conductivity remains constant, and steady state conduction conduction equation is there. So three-dimensional, out of three-dimensional, if you have only two-dimensional, the z axis gets cancelled. Am I correct, students? Am I correct?
Yes, sir.
Okay, so dou square T by dou Z square becomes 0, and there is no internal heat generation. So Qg by K will become equal to 0. And if it is steady state, the right hand side dou T divided by dou T. Capital T is temperature, small t is time. That is also becomes 0. Am I correct?
Yes, sir.
What are you people are what? This is the equation, na? So when you take two-dimensional, what happens is this becomes 0. Dou square T by dou Z square becomes 0. Qg by K becomes 0, or G by K becomes 0. And if it is steady state, this term becomes 0. So you will be having only dou square T by dou X square plus dou square T by dou Y square equal to 0. Am I correct? Am I
Yes, sir.
correct or not? So for this, we have used partial derivative techniques. We have used conduction shape factor techniques, and we have the third technique which is available is no finite difference technique. Okay, so in case of finite different techniques, okay, we have 4 points. Okay, for assume that the center point is mn. Okay, the center point is mn, and assume that q1 is the heat transferred from m comma n plus 1, and q2 is the heat transferred from m plus 1 comma n, and q3 is the heat transferred from m comma n minus 1, and q4 is nothing but the heat transferred from this node that is m minus 1 comma n. Okay, and this distance, the distance along the x-axis is del x, and the distance along the y-axis is del y. All of you are able to understand this, what I'm saying? The center point is m comma n. Students?
Yes, sir.
Yes.
Yes, sir.
Yes, sir.
Or if you want me to write like this, then if you assume this as 5 and this as 1, 2, 3, 4, then q1 will be equal to this one. Okay, t1 minus t2. Okay, and similarly like this. Okay, so for this, okay, that's why they have given m comma n. Okay, m comma n at the center, and m comma n plus 1 on the upper side, m comma n minus 1 on the lower side, and on the right hand side m plus 1 comma n, and on the left hand side m minus 1 comma n. Okay, and the distance generally we take it as del x. The distance we generally take it as del x along x axis and del y along y axis. Okay, del y along y axis and del x along x axis. Is it fine, students? Is it fine?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so now what happens here is you can see here from this point to this point, it is half of del x. Am I correct? From this
Yes, sir.
point to this point, it is half of del x. Okay, or yeah, here in this you can see from this point to this point you have del x. So from this point to this point, it is del x by 2. Similarly, from the other side on the y-axis side also it is del y by 2. Okay, so for this only they are mentioning dou square t by dou x squared m comma n is equal to approximately equal to dou t by dou x m plus half comma n minus dou t by dou x m minus half comma n divided by del x. Okay, or dou t by dou x m minus half comma n is approximately equal to t m comma n minus t m minus 1 comma n divided by del x. Okay, and similarly dou t by dou x, m plus half n approximately equal to t m plus 1 n minus t m comma n divided by del x. Now when you substitute these two values here, then dou square t by dou x squared m comma n will be equal to approximately equal to t m plus 1 n plus t m minus 1 n minus 2t, because this minus this, okay, m plus 1, so this value minus this value, okay, so t m plus 1 n plus minus of minus t m minus plus t m minus 1 n and minus 2 t m n divided by del x squared. Is it fine? Is it fine?
Yes, sir.
Why I say
Yes,
del
sir.
x squared? You may ask a question, sir, the del x is common, so the del x will be coming here, but that del x divided by this del x will become del x squared. All of you are able to understand this? Why
Yes, sir.
del x squared comes in the bottom?
Yes, sir.
See, already you have this expression. See, for this, you have del x in the denominator. Similarly, for this, del x in the denominator. When you substitute these two here, the whole thing divided by del x. So that becomes del x squared. See, some of the students, they will be asking me, sir, how come here you have del x, here you have del x? What about del x squared? So the whole terms divided by del x, so this becomes del x squared. Is it fine?
Yes.
Yes, sir.
Students, all of you are able
Yes.
to understand, because in the data book, the formula will be given. So immediately you can write the equation without knowing this concept. That's the problem. And see this. Now what happens is we know that q equal to minus ka dt by dx. Okay, so in the case of dt by dt, we have tm n plus 1 minus tmn divided by del y into del x minus ka dt by dx. Okay, so in that form is given like this. Okay, and for q2, q3, q4, it is written like this. Okay, so if this center point is mn, okay, if this center point is mn, m minus 1 comma n, m plus 1 comma n, m n plus 1, m n minus 1, then we know that q1, q2, q3, q4, q1, q1 from this, q2 from this, q3 from this, q4 from this. Now again you may ask a question, tm n plus 1 minus tm1, that is the rule. So why it is so? Because the direction is from this point to this one. So t comma or t within bracket suffix m comma n plus 1 minus tmn. Okay, so from this direction, from this point to this point, from this point to this point, from this point to this point, so this will be coming first and m comma n will be at the end. All of you are able to understand this?
Yes, sir.
Students, so
Yes, sir.
q1 is from this point, I'm sorry, from this point to this point. So t suffix m n plus 1 minus tmn. All of you are able to understand this?
Yes, sir.
Yes,
And
sir.
similarly q2 is from this point to this point. So t suffix m plus 1 comma n minus tmn. Okay, from this to this, from this to this, from this to this. All of you are able to understand, students?
Yes, sir.
Yes, sir.
q1 from this point, q2 from this point, q3 from this point to the center, q4 from this point to the center. So the center point is t suffix m comma n. So it comes at the second side. Okay, or t m plus 1 comma n minus t m n. Is it fine, students? Is it
Yes, sir.
fine? Now dou square t by dou s squared uh, plus dou square t by dou y squared equal to 0. Now, when you assume or when you write the equation like this, you will be getting tm comma n plus 1 plus tm comma n minus 1, tm plus 1 comma n plus tm minus 1 comma n minus 4t mn equal to 0. Right? So, this is the general equation, or to find this t comma tmn, this is the formula. The formula is tmn, which is equal to tm n plus 1, tm n minus 1, tm plus 1 n and tm minus 1 n divided by 4. Suppose if I give you a simple problem for like this. If I give you a simple problem like this, 50 degrees, 25 degrees, 20 degrees, 10 degrees, what is the temperature at the center? Then you can use this expression. You can use this expression to find out. Okay, students? Am I correct?
Yes, sir.
So if I give you the formula like this, then you will be able to find out the center temperature is 50 plus 25 plus 20 plus 10 divided by 4. That will be the answer. So 75, 95, 105. 105 divided by 4. How much it is? 22.5. Please correct me if I am wrong.
Yes.
Students, all of you are able to understand this? How I got?
Yes.
Yes, sir.
Okay. All of you understood this? The equation, ma? The
Yes, sir.
equation and how I am getting if we have 4 nodes, assuming that this point is at 10, this point it has 25, this point at 50, and this point at 20. Under the assumption. Okay. Okay, students?
Yes, sir.
Yes, sir.
Okay. And in the data book, you may ask, sir, you are saying this and we have open book and all. In the data book, this formula is here in page number 54. Interior node. How to get the temperature of the interior node if you have 4 nodes like this. Is it okay, students? 1 by 4. So there is no need to memorize the formula. Just you have to think and you have to apply. Suppose instead of the nodes at a particular temperature, if the side is exposed to a convection boundary, just like what you have in the iron box. The iron box surface is at say 70 degrees or 80 degrees, but it is exposed to still air in our house, right? So that boundary can be assumed as a convection boundary, right? Because the air will be at 25 degrees or 30 degrees in our house, and the iron box surface will be at say 70 or 80 degrees, or sometime 80 or 90 degrees or 100 degrees, whatever it may be. Okay, so that boundary surface will be assumed as a convection boundary. It depends upon case to cases. Okay, so in that case you have to use this formula. So for that also we have the expression. Okay, now by means of energy balance method, we can find out, and we have got this different conditions. Okay, so node interior node and node at an internal corner with convection, node at a plane surface with convection, and node at an external corner with convection, node at a plane surface with uniform heat flux. So there are so many things which were there, right? And so usually what happens is you will be given a problem like this. See, this is what it depends upon so many iterations. That's why nowadays we use some softwares. Okay, softwares were used to find out the solution. So suppose if you are even matrix MATLAB, right? I think you people, you have studied MATLAB. Okay, and you will be having so many equations like this. Okay, so after getting the equation, when you use the MATLAB, you can find out the solution. Now usually the problem will be like this: T 100 degrees C, T 100 degree, T infinity 100 degrees C, T infinity 100 degrees C, T 500 degrees C. So these two boundaries were at fixed temperature, and these two boundaries were convection boundary. Am I correct?
Yes, sir.
Yes, sir.
Surface with convection boundary, the bottom and the right hand side, whereas the top and the left hand side were at fixed temperatures. Okay, so if you are given a problem like this and with thermal conductivity 10 degrees C, and what happens is you will not be able to solution, but you can write the equation, right? You can write the equation. Am I correct? Am I
Yes,
correct,
sir.
students? So for particularly for point T1, if for point T1, we know that T1, to get the equation for T1, 500 plus 100 plus T2 plus T4 minus 4T1, which is equal to 0. Am I correct? 500
Yes.
plus 100 plus T2 plus T4 minus 4T1 equal to 0. Am I correct or not? This is what
Yes,
I
sir.
said. All of you are able to understand this, ma? For writing the equation for T1, 500 at the top, assuming it coming to the center, 500 plus 100 plus T2 plus T4 minus 4T1. Okay, so you may ask, sir, how you have written this? I am using this. Tm comma n, I have used this. 1 by 4 of Tm plus 1 n plus Tm n plus 1 and Tm minus 1 comma n and Tm n minus 1. All of you are able to understand this, students?
Yes.
Yes.
Sir.
Okay. And similarly, for the second surface, for the second, for example, if you want to take for T2, then the equation becomes 500 plus T1 plus T3 plus T5, right? So not T3, this is exposed to convection boundary. So in that case, in that case, what happens is you will be getting the difference. For T3, you will be using this 2 1 by 3 T3. So you may ask a question, sir, why for nodes 3, 6, 7 and 8, or why you are using this equation? So for nodes 6, 7, 8 and 3, for nodes 6, 7, 8 and 3, why this particular 3, 6, 7, 8? These were exposed to convection boundary. Since these were exposed to convection boundary, you have to use this Tm comma n, which is equal to 1 plus h del x by k plus 2. This equation you have to use convection boundary. Is it fine, students? Is it fine?
Yes, sir.
I don't know. Only one
Yes.
fellow is saying yes. 3, 6, 7, 8. You have to use this. For 1, 2, 3, 1, 2, 4, 5, you can use the first interior nodes. Okay, one interior node equation can be applied to 1, 2, 4, 5. For 3, 6, 7, 8, this convection boundary equation has to be applied. And exterior corner convection boundary. Okay, exterior corner convection boundary m comma n. This equation has to be applied for T9. Is it fine?
Yes, sir.
Yes, sir.
Yes.
So 1, 2, 4, 5, the first equation. 1, 2, 4, 5, 1, 2, 4, 5, the first equation. And for 3, 6 and 8, 9, sorry, for 3, 6 and 7, 8. For 3, 6, 7, 8, the second equation. And for 0.9, the third equation. T9, which is equal to. Okay, so you can write this equation, and after writing this equation, you can feed it to, because there will be so many variables. Okay, there will be so many variables. So that's why the equations are different for 1, 2, 3, 4, and similarly for 1, 2, 4, 5, and it is different for 3, 6, 7, 8, and it is different for 9. Is it fine, students?
Yes, sir.
Shall I give you one assignment like this? Shall you write the equation, and shall you, with the help of computers, if you have any software, can you find by the temperature by means of iteration like this? 280, 330, 309, 192, 175 like this? Or at least shall you be in a position to write the equations, ma? All of you?
Yes,
We can write, sir.
Yeah, okay, ma. Anyway, I will discuss this again in the next class also. With this, I stop. for the day. I'll stop the recording because the time is 8:55. You have to attend other class.